All right, so when they say find the area of a triangle in terms of theta, what does that tell you? Theta has to be in your answer, and there isn't going to be a result like 7, because right now they're saying that in terms of, meaning you're going to say the area equals something something with theta as part of your answer. Again, that's what this little phrase in terms of, it means you're going to have an equal sign with that variable as part of your equation. So area, we want to know OBP. How do you find the area of a triangle? Half base times height, or what we need to use is that formula. And where did that formula come from? Came from that triangle, or any triangle. But what it's saying is angle C is kind of the reference angle. And so if I'm looking at this, I'm going to call this angle C. And so here could be, I'll use B. I'm going to make that A instead. So there's A down there. Letters are labels. So I have 1/2. A is 2. It's the radius, and so that's the radius. 2 times 2, because that's B, times the sine of theta. Done. That's why it was 2 marks. Write down the formula with the numbers in the right place, simplify. Why are these 2 triangles, why do they have the same area? The red triangle has the same area as the blue triangle. We could call this a length. This is 2, 2, and 2.
Well, what if it's not an isosceles triangle? It is. 2 sides are equal. What if it's a different question and it's not an isosceles triangle?
It's still going to, if it looks like this in a way, it's still going to have the same area.
But what if they write like not drawn to scale?
Yeah, that's okay.
But I think that those 2 are sunrise.
What if they don't give what? You'll have to. Do I even need to know the radius? Nope. Don't even need to know the radius.
Yeah, but you know that O is the center point.
We know O is the center point, which means
That A, O, and OB are equal.
exactly. Those 2 lengths are the same. Yes. We're going old school now. How do you find the area of a triangle?
Half AB, no, BH.
Half base times height.
Oh,
Same base,
same half.
same height. They're equal. Since O is the midpoint, therefore AO equals OB, same base. P is basically the height for both triangles. They're equal. We ready to move on to the next part? Okay. You just proved up above that the area of this triangle is 2 sine theta,
They both have the same area.
right? So this area is 2 sine theta. This area is 2 sine theta.
So it's, you have to find the area of semicircle minus twice.
Exactly.
The area of semicircle is 1/4 times pi r squared.
Pi r squared over, yes, the semicircle area is pi r squared divided by 2. minus then our 4 sine of theta. The radius we know is 2. So pi 2 squared over 2 minus 4. I'm making that a lot longer than it needs to be. Again, show that means make your answer look like theirs.
So it will be pi minus 2 sine theta.
Yep. The 3 marks, basically 1, 2, 3. You actually didn't need to write kind of this middle little part that I wrote. You wrote down the formula, and actually, I take that back. You didn't need to actually write the first step, showing it's pi r squared. You could have done pi 2 squared over 2, started right there. So there's 1, 2, 3. Find the value of theta when S is a local minimum. Justifying that it is a minimum.
Oh yeah, and then you substitute x into the derivative.
Close. So let's first, yes, finding local maximum and minimums. We take the function, we find the derivative. Okay, so right now, the derivative of this function as sort of theta changes. What's the derivative of this? What's the derivative of 2 pi?
Nothing.
0. So minus 4 sine theta, what's the derivative of 4 sine theta? Derivative of sine x is?
Isn't it the product rule?
It is. But again, yeah. So sine of theta or sine of x becomes cosine. All right. So we have negative 4 cosine.
Minus sine, plus sine.
Plus nothing. This is the product rule. So this became 0.
Oh, yeah. Right.
Yeah?
Yeah.
Okay. Now, so we know what the derivative is of this formula or this function. So how do we know when it's a maximum or minimum?
The other negative.
That's second derivative. So if we did the second derivative, we could, but yeah, but what yeah, the plus minus, but what's in the middle? 0. The maximum or minimum is when the derivative is 0. So what we're really now saying is maximum or minimum, negative 4 cosine has to equal 0. Divide by negative 4. When is, what's the value of theta for cosine to be 0? 90, or because we're dealing in radians, pi over 2. Your marks are coming A, of doing the derivative, B, setting the derivative equal to 0, C, actually finding what that is. And your justification basically happens right here. You know, that a derivative finds maximum and minimum values. Minimum, maximum happen when it equals 0, and here's when it equals 0. So there's one method. Now, a second method is more of a logical method. Method 2. Method 2 makes you think, when is S going to be the smallest value? That's when it's at a minimum. And if you think about it, 2 pi minus 4 sine theta, this will be, when you're subtracting two numbers, it has the smallest value when the second number is the largest possible. Does that make sense? So if like this was 0, but if it was 1, then you're 2 minus 1, 2 minus 2, 2 minus 3. So making this number as big as possible makes S as small as possible. So when is S the smallest value? When 4 sine theta is the largest possible. When is 4 sine theta the largest possible? And here we can actually go off, if we want, 4 sine theta, amplitude of 4, still the sine curve. Or, and there you've just justified for me that when say theta is pi over 2, S is a minimum.
Is this for D still?
Yeah. Like I said, there are a couple of ways you could actually approach it. One is actually doing the derivative, because we know through calculus that minimum values happen when it's 0. And then here, this is kind of more a logical, things are smallest when we subtract the greatest amount. So that works. So when does it have its greatest value? If we make 3 pi over 2, it has a value of negative 4. And so we're actually subtracting negative 4. So adding 4. And done.
That's part E.
Yeah. So for part E, and again, seems a bit complicated, I realize. I'm like trying to think out loud for you to show here's what I'm thinking. And if I were to go back to the start, yeah, my thinking like for part A, it's just we have this formula for the area of a triangle. For part B, why are triangles the same? Well, base times height, if those two pieces are the same, the triangle has to be the same, the areas. And so that was like my logical thinking there. It's like, how do I know two triangles have the same area? Their base and their height. If I know those two things are the same, then it's there. And so I looked to see, is that true? And that worked out. And then to show that, you guys pretty much had that yourselves. You know, that you already knew that these two areas were the same and that they were 2 sine theta. So area of the semicircle, take away the two triangles, done. Yeah, when's it a local minimum? I mean, Nadine started off with, okay, find the derivative of the function, because we know derivatives connect with max and minimum. Now the one thing I think you kind of forgot was, oh, I have to set it equal to 0. That's when it's a maximum or minimum, when it's set equal to 0. Okay? And again, then there's actually a second method of not actually having to do derivative. And would I have logically thought of that right away? Not necessarily. My first approach would have been find the derivative, set it equal to 0, and then solve from there. That's true. And then once I knew that, okay, then the maximum basically has to be, going this opposite